Hello everyone, today we're going to go over the Blind 75 in C++, and today we're working with Palindromic substrings. Now, before we get started, feel free to pause the video, since we are breaking down the question accordingly. We need to ask ourselves these 4 questions. If you're following along, again, feel free to pause the video to write out the comments that we have. For every time we see one of these questions, we need to ask ourselves these 4 questions. We need to ask ourselves what the input's going to be, what data structure / algorithm / technique to use, what to do with the data, and finally, what our output's going to be. So now, breaking down the problem. Given a string S, return the number of palindromic substrings in it. A string is a palindrome when it reads the same backward as forwards. A substring is a contiguous subsequence of characters within the string. So, to be able to give a breakdown on the following examples that we have, like say for example that we have A, B, C, and if we were to have the output of 3, we're given 3 palindromic substrings of A, B, and C, since it reads the same forwards and backwards. That's what a palindrome is by nature, and we have to figure out how many combinations there are. So it looks like we need to return the number of combinations for palindromes with our given string, and here we are given a string S for our input. And the technique that I will be introducing you folks to actually going through on how to break down for the following string is going to be dynamic programming, which is great for reading data both forwards and backwards. And the steps for us to be able to accomplish the following task are going to be the following. Steps 1. What we're going to do is that first we need to initialize the string length and the matrix that will have the string length on the inside to check to see if there is a palindrome, and then if so, it will be true, such as like having A, B, C. So we need to divide up accordingly based on our following string. And then the second step, we're going to create a count as well. Then we are going to iterate through our string S. Most likely it's going to be a for loop. And then for the first part, we're going to iterate backwards. And we're going to do this by the following. We will set dp we will set our given array to be true, indicating we have one string, one palindrome substring. Then the next part, we're going to increment our count since we're moving up. We're going to increment our count to indicate for the number of our substrings that we have. Then we are going to iterate forward. And then for this part, we will check to see if the character at index and the current index is the same as the character current forward index is the same as the character in the backwards index. And in this case for dynamic programming, there is a strong chance, since looking at data both forwards and backwards, we will use a nested for loop. That's just a probability, just something to keep in mind. I will explain more when we are writing out more of our solution. And then the second step is that we're going to check the length of the substring and if the characters at the same substring and also we're going to check the length of the substring if the characters at the same substring with if the characters are the same substring with the length of the substring is 2, then it will be a palindrome. And finally, we're going to return our count. So now, just to clean up everything and then showcase you folks exactly how we're going to write this out in our 4 steps. So we have step 1, step 2, step 3, step 4. Here we go. So int n is going to be s.length, and then we're going to have vector bool, vector boolean to be able to check to see if we have a palindrome, and we're going to initialize this as dp. So then our parameters for it are going to have a vector with a boolean to indicate it's false, and this is just how we initialize if we have any type of this is how we're going to check to see in particular if we are going to have a following palindrome, and this is just how we initialize it. Then we're going to initialize our count, and then we're going to iterate forward by actually, in the palindrome sequence, we look at the data backwards and forwards. So in this case, since we are going to be iterating backwards to begin with and then forward, our for loop is going to look unique. So we're going to treat it like I, but instead it's going to be n minus 1, since starting from the very last elements within our given string. And I is going to be greater than or equal to 0, since we're iterating from the back, and then I is going to be decremented. Then what we will do is that we're going to set our current index to true. So dp of I, so let me just put this as 1. And right here, this is how we initialize further, and then we're going to increment our count. Then we will continue inside of our for loop, and this time we're going to iterate forward, so it's going to be b. And the way we do that is that we're going to have int j is going to be I plus 1, since we want a palindrome. J is going to be less than n, where n is referring to our length that we initialized up here. You can even have the for loop as well, s.length, but for the sake of clarity, we just put n, and then j is being incremented forward. Then we are checking for 1 and then 2. So we're going to follow the guidelines. We will check if the character at the current forward index is the same as the character at the backward index. And the way we do that is that if s of I at the current index and is equal to s of j at the forward index, and we subtract the displacement from the following, set it equal to 1, and j minus I is equal to 1, indicating just the space that's in between. After we have iterated forward and backward, that we have this number. We are then going to call upon a vector to be able to check to see if it is a palindrome, and then add it to our count. So we have I plus 1, and then j minus 1, because if we're incrementing it, this is at the point where it will be backwards, and then this will be forwards as well. But we are checking to see when they finally sync up to each other, because we're checking the length of the substring. We are checking to see if the character at the current forward index is the same as the character in the backward index, and we're trying to see in particular when they meet up. So this is why in particular that we have these two components for in our DP vector, so to speak. We're moving forward, so DP of I and j is going to be true. Therefore, we're going to increment our count, because we need to check to see if it is a valid palindrome. And then finally, we are going to return our count. Oh yeah, also, this was also part of step 2 at the same time. So we're going to check the length of the substring and 2. Sorry for the confusion over here. So that is how we will set this up. Let me just double check. Alright, passes all the test cases. Alright, and it works pretty efficiently. So to be able to give a rundown and breakdown of our space and time complexity for our following solution is that given the fact we are using a nested for loop, the time complexity for our solution is going to be O of n squared, where n is the length of the substring s, and this is because we fill the Boolean matrix of the dynamic program of dp based on size n times n, and each cell requires constant time to compute based on the previous results. While meanwhile, the space complexity is going to be a O of n squared, as we use a Boolean matrix of size n times n to store the results of the subproblems. And yes, this was Palindromic Substrings. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put in the comment section. And as always, take care. Cheers. Bye-bye.